All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Warm-up 81 is on the screen. Let's get started, please. Some of you already got started a long time ago. By now, these should be a piece of cake. I brought back solving quadratic equations on number 1 and number 3. Hopefully, you should know how to do those by now. And number 2 is transformations. And number 4, of course, it was what you studied last night, yes? All right, good. So I'll give you guys some time for that. And go and let me see, show me how many minutes do you want for the warm-up? Let's see. I see 3, 2, 23. No, not 23. Anyways, 5 minutes. How about that? Yeah? All right. Go. Jacob A. What'd you do for number 1? Oh, it's right there. You can get it right there. Oh, okay. Then get me started. Let's go. Change it to 0. 3x squared plus 27. Next, what do? We need to solve for x. Close. That's almost the last step. Subtract 27. Subtract 27. That is correct. 3x squared. Oh, my bad. Let it go. Let it go. Have you guys heard that song? And you said what? Divide by 3. Divide by 3. X squared equals negative 9. Square root it. X equals plus minus 3i. Hands, if you got that? That is correct. Let's go from the corner. Get it from the corner? Anyway. All right, let's go with number 2. Number 2, it's a transformation. Let me make some space here. All right, so by now we know how to graph the parent function f of x equals x squared without a table. It's right here. Tell your neighbor the vertex for that one. What is the vertex for that one, please? Vertex. Vertex for that one. Rylan. 0, 0. Yes, 0, 0, which is right there. All right. So with that said, we need to write our rule given this. So instead of A, we write 1. Instead of B is 1. Instead of H is 3. And instead of K is negative 4. Therefore, G of x equals 1 times F, 1 over 1, x minus 3 squared minus 4. Do we need to write the ones? No. G of x equals f of x minus 3 squared minus 4. Therefore, tell your neighbor the vertex for the new transformation. Talk it over to your neighbor. What is the vertex of the new transformation? Vertex of the new transformation. All right, looks like Rylan's got it. Let's see, Rylan, vertex of the new transformation. That is correct. And he saw that because of H and K. 3, negative 4, so we go 1, 2, 3, and then 1, 2, 3, 4. So my new vertex is down there for G of x. And if you got something like that, all right. Let's go to number 3. Number 3, solve by completing the square. Oh, I love these. And we just took a part a couple weeks ago. Some of you are still in the middle of retaking those or finishing up. However, the rest of us, we wake up and we're like, completing the square. All right? So, Rylan, pass someone. All right, now I pass it back to Rylan. Go. make y 0, so x squared minus 8x minus 10 equal to 0. Okay. There's 5 methods of solving this. Once again, they were what? Graphing, square roots, factoring, completing the square, and quadratic formula. Which method do you want to use for this one? Square root? All right, so that means you're going to do this one? Okay, pass someone. Maya, A, which method do you want to use to solve this one? Graphing, square root, factoring, completing the square, or quadratic formula? Square roots? Okay, let's try square roots. Here we go. Oh, wait. It says by completing the square. What? All right, so help me out. Maya, what do I do from there? Add 10 to both sides. All right, that leaves us with x squared minus 8x, empty space, equals to 10. What's the next step? Tell your neighbor, and then Maya's going to pass it to someone. Next step. Pass someone, Maya, A. Martin, what do I do next? Negative 8 over 2 squared. You add that to each side. And Martin, let's go. So therefore, this is x squared minus 8x plus, this is negative 4 squared, that's 16, equals to 10 plus 16. So far so good, yes? All right, can I simplify this side? Yes. So this is x squared minus 8x plus 16. What's my next step? Pass someone, Martin. Okay, so square root for the shortcut, you mean? Yeah, so square root of the first is x. Square root of the third term, that's 4. Use the sign of the middle term and write that squared. Thank you. So far so good, yes? What do I do next? Pass someone, Brandon. Oh, he's not here, so Anthony E. Go. What do I do next? Yes, now we square root the whole thing, both sides. Here and here, this cancels out. X minus 4 equals plus minus 26, or square root of 26. But right now, we're going to leave it exact. I don't want the decimal form. And my last step, tell your neighbor what it is, and then Anthony's going to pass someone. Last step. Pass someone, Anthony. Danny? Add 4, x equals 4 plus minus square root of 26. These are my 2 solutions. Tell your neighbor the 2 solutions. What are the 2 solutions? X of 1, x of 2. What are my 2 solutions? Pass someone, Danny? Martin? Square root of 26. That is correct. Those are my 2 solutions. Exact. All right? So, with that said, let's go to, was that the last one? Oh no, the last one's here. Number 4. Voltage for number 4. Pass someone, Martin? Brandon Doherty, what you get for the voltage going through the capacitor? The what? The resistor? Oh, the resistor. You did the resistor? Oh, okay. So this one, they're only asking for the what? Capacitor. So what you get for the capacitor, Anthony D? Voltage. Minus 144. 144? 144I. Hands if you got something like that. That is correct. Double check your work. Make sure you use your formula. And when it gets to these, you don't have to do the whole thing. Just go straight to the capacitor. And the capacitor, remember, that's a negative I. Negative I. Okay? Copy the agenda, please. Warm-up number 81, complex numbers. And tonight's home play is a play sheet. I'm going to give you the code in a little bit. And it's numbers 1 through 12 only. So today we're going to wrap up this portion of quadratic equations because we're about to embark next week on quadratic functions and all the transformations that come along with that. And we've been talking about complex numbers. Today we're going to be talking about complex solutions, and that involves real and non-real, real and non-real, okay? And today we're going to revisit our graphing. Let's see how well we got. I mean, I've been giving you plenty of practice on the warm-up, so that should go a lot faster than what we think, right? Yes, Mr. Q. All right, good. All right. So with that said, here's your code. 3RDBZ. 3RDBZ. That's going to give you access to the home plate. All right? So make sure you get that done. And just a reminder, in case some of you forgot, there's tutoring, and it's what? Free. Yes, yes. So you're welcome to join us. And what do we do during the tutoring? We finish the home play. Bah! My goodness. And of course, without the aid of electronic sources. Anyways, so last night you studied your electric circuits and complex numbers, so I could give you a pop party right now. Is that correct? We'll wait till tomorrow, I guess. All right. So, all right, let's get a Cornell note ready. I can identify complex solutions in quadratic equations. I can identify complex solutions in quadratic equations. And once you set your Cornell note, I want you to make a coordinate plane on the right-hand side or in the center, that's fine, from negative 15 all the way to 15, both ways, for x and y. Negative 15 to positive 15, both x and y. I'll give you some time for that. Go. All right, here we go. Our objective for today, I can identify complex solutions to quadratic equations. So we finally finished our introduction, and we've been doing work with a lot of complex numbers. And then from there we went to electric circuits. We still work with complex numbers. Today we're going into equations, quadratic equations, and looking at it through the lens of complex solutions. Okay? So before I go to complex solutions, remind your neighbor what complex numbers are. Remind your neighbor, what are complex numbers? Complex numbers. Complex numbers. Let's go. All right, let's see. Looks like Brandon's got it. Oh, wait, Brandon Doherty wasn't here. Brandon Doherty, complex numbers. One real and one imaginary. So think about that. That is in regards to numbers. So therefore, if I was talking about solutions, what would that look like? Share with your neighbor, what would that look like in regards to a solution? X equals a complex solution. All right, good communication. My goodness. Isn't it funny, like, when teachers say, no talking, everybody's like, blah, 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 and then I Insta and da-da-da-da. And then when I tell you guys to talk, and it's like, anyways, Brandon, pass someone. Noah, complex. Help him out, Jacob, M. So I want to write a complex solution, such as x equals, what would that look like? If Brandon Doherty earlier said that complex numbers are a real and an imaginary. Ooh-wee. So if that's x1, tell your neighbor what x2 looks like. Right? Pass someone? Martin. That is correct. 5 minus 2i. That's what we're going to be looking at today. So, since some of you are still needing some clarification, on your paper, write this down underneath your coordinate plane. Right. Identify real solutions in a quadratic equation. Identifying real solutions in a quadratic equation. Identify real solutions on a quadratic equation. On the left side underneath that, I'm going to write real solutions. And on the right side, I'm going to write non-real solutions. And in parentheses, next to non-real, you're going to write square root of negative. So, let me start with simple real solutions. When we solve a quadratic equation at the end, the simplest one would be x equals plus minus 3. What are my two solutions here? X equals 3 and x equals what? Negative 3. Are those real numbers? Yes. Okay, that's one. So when we're solving at the end, if it looks like that, I'm going to ask you, is it real or non-real? It's real, Mr. Q. There it is. Here's another one. X equals 5 plus minus 3. Is this or are these solutions real? Yes. 5 plus 3, that's 1, and 5 minus 3, that's another. Are they real? Yes. Okay, so write that down. So this is example A, this is example B. Let me give you one more. X equals 5 plus minus square root of 26. This is example C. Is this a real solution? You're like, let me see, Mr. Q. Can I take square root of 26? I can, but I end up with a decimal. But since our decimals are real numbers, yes, so therefore this is also a real solution. The only thing, this is what we call what? Exact solution. Okay? So what does non-real look like? Well, let me go over here to this side. X equals, and by the way, if I was to solve using square roots, the last step before I get to this one was what? Square root of 9, which is plus minus 3, right? So let me show you non-real. Plus minus square root of negative 9. That's a non-real solution. Why? Tell your neighbor what would be x1 and what would be x2. x1 and x2. What is x1 and x2? You help me with this one, Emily P. 3i. Negative 3i. Yes, that is correct. That's why they're not real, because these are what? You guys seen that? Did you guys grow up with SpongeBob? Anyways, imaginary. So since they are imaginary, then they are not real. Bah! Here goes another example. X equals 5 plus minus square root of negative 16. Tell your neighbor the two non-real solutions for that one. Emily P., pass someone. Courtney Jean. Hands if you got that. That is correct. They're not real because they are imaginary. So, before we move on, tell your neighbor the difference between real solutions and non-real solutions. What's the difference from one to the other? Yeah, the I, or that there's a negative inside the what? Square root. We got it? All right, so that takes us to this problem. All right, you have your coordinate plane? Everybody there? All right, so copy this. Graph and state how many real solutions. Y equals 2x squared plus 4x plus 1. All right? So, graph and state how many real solutions this has. So this is the first thing I'm going to do. Check this out. I'm going to set this equal to 0, 2x squared plus 4x plus 1. Next, let's get rid of the constant. What is the constant? 1, so I subtract 1, subtract 1. So I end up with negative 1 equals 2x squared plus 4x. Okay? So, at this point, I'm going to make this into a system. All right? Look up. I'm going to take the constant and make this g of x equals negative 1. That means that whatever's left over that was part of the original, that is my f of x, which is 2x squared plus 4x. Write that down, please. All right? So, let's graph this. I'm going to start with f of x. So let's make a table, x, f of x. Tell your neighbor the values that we're going to use for x. What values do we use for x, everyone? Let's go. Negative 2, negative 1, 0, 1, 2. All right? So I'm going to zoom in so you can see. Oh, my goodness. Bah. I'm going to zoom in. I'm going to use this equation, the f of x, to substitute my x values and get our f of x. So here we go. I'm going to use this part. 2 parentheses squared plus 4 times parentheses. All right, so here we go. My first value. What is my first value? Negative 2. That goes here and that goes there. So, what is, we do the exponent first. What is the negative 2 squared? 4. And then let's do multiplication. What is 2 times 4? 8. What is 4 times negative 2? Negative 8. So this is 0. Let's do it again now for the next value, which is negative 1. 2 squared plus 4. And we're going to substitute the next value, which is negative 1. So what is negative 1 squared, everyone? 1. What is 1 times 2? 2. What is 4 times negative 1? Negative 4. So this is negative 2. Next, 2 times 0 and 0. What is 0 squared? 0 times 2, 0. 4 times 0, 0. So everything is 0. Next one, 2 squared, 4. So my next value is 1. So what is 1 squared? 1 times 2, 2. 4 times 1, 4. What is 2 plus 4? 6. All right, do the last one and share with neighbor what you got for f of x on the last one. All right, what you get for that last one? How about Bailey? What'd you get? 16. Hans, have you got 16? That is correct. Okay, so let's graph that one. Let's graph our f of x. Here we go. We got negative 2, 0, negative 1, negative 2, 0, 0, 1, 6, and 2, 16, somewhere way up there. So I'm going from left to right. Something like that, yes? Okay. So now that we have our f of x, let's label this one f of x. We need to graph g of x. So look up in blue. G of x is going through what number? Negative 1. So we go to on the y-axis to negative 1, which is right here. And it's a straight line going through there. There it is. All right. Now let me pause the tunes in the back. Sorry, Beastie Boys. All right. Look up, please. So, looking at this equation, what did we do? Set it equal to 0, got rid of the constant. That became a system. My system consists of f of x and g of x. We graph f of x. This blue one is our g of x. And I can tell you, look up, I'm going to say this has 2 real solutions. Let me zoom in. Tell your neighbor why it has 2 real solutions. What do you think it has 2 real solutions? 2 real solutions. Now think back to the warm-up from this week. We had a system of equations. We came up with a point, and that point was what? Tell your neighbor. What was that point? We're both what? Okay, so this one has 2 real solutions. Tell your neighbor why this one has 2 real solutions. Bailey, pass him one. Rylan, why do you think this one has 2 real solutions? 2 intercepts? 2 intercepts in regards to close, very close. What do you think, Jacob? A. All right, hold that thought, because I think we need another example, yes? All right, so on that same coordinate plane, I want you to write over here on this side, I want you to write y equals 2x squared plus 4x plus, give me a number, 2. All right? All right, so we're going to graph this one. So what is the first thing we do, guys? Here we go. Let's follow the process. Set it equal to what? 0. 2x squared plus 4x plus 2. What do I do next, Anthony E? Minus 2. Do that in green. Minus 2. So it's negative 2 equals 2x squared plus 4x. Now we can make a system. Tell me what to write for my system now that we have this. Anthony, pass someone. Martin. G of x equals what? Negative 2. And f of x? Yeah, 2x squared. 4x, okay. Now look up, guys. Do you guys see that this, I gave you this so it can be the same as this one? So do we need to regraph it? No, we already have it. What is the only thing we need to graph? G of x negative 2. So negative 2 is right here. For this one, look up. For this one, only one real solution. Only one real solution. The blue one, 2 real solutions. The green one real solution. Talk it over to your neighbor, let them know why am I saying that. Why am I saying 1 real solution for the green one and 2 real solutions for the blue one? All right, looks like Danelli's got it. Very good, Danelli. All right, enlighten us, Danelli. What do you think? Why the green one real solution and the blue one 2 real solutions? So this system right here, 2 solutions. This one real solution. Dom, enlighten us. All right, we're getting closer. Laura, what do you think? So the green one only intersects once with the f of x, and the blue one intersects how many times? Twice. That's why that one has 2 real solutions. Oh, let's do one more to clarify. On this side, I want you to write y equals 2x squared plus 4x plus, give me a number, 3. So write me the new system for that one. And do that one, the g of x in red for that one. All right? All right, help me out. Corny Jean, what do? Subtract 3 from both sides. So 3, or negative 3 equals 2x squared plus 4x. So my f of x is still 2x squared plus 4x. But my g of x, my new one, is negative 3. Okay, so negative 3 is over here. So for this system right here, I'm going to write no real solutions. Tell your neighbor why. Why no real solutions for that system? Why no real solutions? Why no real solutions? Breathe. Because it doesn't intersect f of x or g of x. So, let's write a little summary. Real solutions is when f of x, what? What's the key word? Intersects what? G of x. That is correct. And then write 10q. Okay, now what that means? Thank you. Thank you. Anyway. From 1 to 5, how comfortable are you with these? Because you're going to have a couple of these on the home plate. We got it, right? All right. You're like, Mr. Q, but I don't want to be graphing all night. Okay, then let's go with some without graphs. Copy this one. Example number 2. State the number of solutions without graphing. Without graphing. Y equals 2x squared plus 4x plus 2. 2x squared plus 4x plus 2. Oh, plus 1, my bad. Oh, yeah? Plus 2. All right, example 2b. Here we go. So, first things first. Step 1, standard form equal to 0. So, we set it equal to 0. 2x squared plus 4x plus 2. Is it in standard form from highest to lowest degree? Yes, okay, so step 1 is done. Step 2, ID, A, B, and C. So, how do you do that? Well, you write your standard form underneath. AX squared plus BX plus C, and all that equal to 0. You guys remember this from the quadratic formula? Yeah? Okay. So, what is A, everyone? 2. What is B? 4. And what is C? 2. Okay, so we got those. Set them aside. Step 3, quadratic formula. Looks like Ryland's got it. Okay, Ryland, I see you. Maya A's got it. All right, Maya, I see you. So, tell your neighbor the quadratic formula without looking at your notes. X equals. Like Denelli's got it. All right, Denelli, I see you. All right, so here goes. X equals minus B plus minus square root B squared minus 4AC over 2A. Okay? Now, do we need the entire equation? No. For step 3, you write the quadratic formula, but in parentheses, I want you to write discriminant. 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 All right, so what is that, Mr. Q? That is everything that's inside of the square root. So we're going to use only that. So let's write that on the side over here. B squared minus 4AC. Now we can actually substitute values. So what is B, everyone? 4. What is A? 2. And what is C? 2. I'm going to bring down the rest. Squared minus 4. So this is 4 squared is 16. Negative 4 times 2 times 2 is negative 16. And this gives us 0. Okay. I'm going to give you a little table over here on the side. When you use the discriminant, if you get a positive number, and write real. Whenever you get a positive number right here at the end after you're simplifying, you get 2 real solutions. When you get a negative number at the end, you get no real solutions. And whenever, what else do we have, either positive or negative? What's the last thing? A 0. Whenever you end up with a 0, it's 1 real solution. So question, how many real solutions does this one have? 1 real solution. You're like, but it says 0, Mr. Q. Yeah, we got 0 to simplify, but if you look at our table, there it is. Now, let's go back to the graph. Look at this one. This was with +2, right? Look up. Where's +2? +2 is right here, or became -2. How many real solutions? 1, because it's the green one. Did we get 1 real solution here? Yes, 1 real solution. How comfortable are you with this so far? All right. So all you use is A, B, and C. You substitute. If you get a positive number, it's 2. If you get a negative number, no real solutions. And if you get a 0, it's only 1 real solution. All right? Last but not least, on your home plate, look up. You're going to have stuff like this that says, solve by completing the square. Do we know how to complete the square? Yes. But remember that at the end, let me go back to my notes. At the end, you need to see if it has real solutions. You end up with something that looks like this. Or if it's something that looks like this, you're going to write no real solutions. All right? We'll stop right there. Once again, home play, you have the code, yes? Yeah, make sure you copy the code. That's home play for tonight. And tutoring after school, be there or be elsewhere, yes? There's your code one more time. I'll stop the video right there. Bye.